In today's class, we are going to focus on solving problems associated with electric charge. Let's begin with number 1. If 4,500 electrons were transferred to a neutral metal rod, what would be the electric charge of the metal rod? So to enable us to solve this question, we have to first of all identify the parameters in the given question. When we do that, it's going to help us to solve it so easily. The first one here is 4,500 electrons. This 4,500 electrons is the number of electrons we are transferred to a neutral metal rod. What would be the electric charge? So it's now asking us to find the electric charge. So the first one we are going to look at there is the number of electrons. The number of electrons, which is N, is equals to 4,500. Then what else we have there is the electric charge. That is what we are looking for, electric charge. Since we have written out these parameters, then we have to look for a formula that relates the number of electrons and the quantity of electric charge. And the formula is quantity of electric charge is equals to the number of electrons multiplied by the charge of electron. So let's go ahead and put in our values. Q is equals to the number of electron is 4,500, then multiplied by the charge of electron is given as negative 1.6 times 10 raised to power negative 19 coulombs. So when we resolve that, we are going to have negative 7.2 times 10 raised to power negative 16 coulombs. So this becomes the charge of the metal rod. So please remember that whenever you are being given a question, the first thing you have to do is to write out the parameters. When you write out the parameters, it is going to help you to know the formula to use in calculating the question. Okay, let's go ahead and look at the second question. It says a rod requires a charge. A rod requires a charge. So here we have our charge. Requires a charge of negative 3.204 times 10 to the power negative 17 coulombs. How many electrons were transferred? How many electrons were transferred? So here the first parameter there is the charge, which is Q, and the value is negative 3.204 multiplied by 10 raised to the power negative 17 coulombs. That is the first parameter there. So the question is now asking you how many electrons were transferred. That means it's talking about the number of electrons. So that is what we are going to find. Now let's look for a formula that relates the quantity of electric charge and the number of electrons. We have the formula as Q, which is the quantity of charge, is equal to N, which is the number of electrons, multiplied by E, which is the charge of one electron. But here, remember that what we are looking for is the number of electron that is being transferred. So we make N here the subject formula. So we now have it as N is equals to Q over E. Then let's plug in our value. Q, we have it as negative 3.204 multiplied by 10 raised to the power negative 17 coulombs. Then we divide it by the charge of one electron. Charge of one electron is given as negative 1.6 times 10 raised to the power negative 19 coulombs. So the charge of one electron is a constant. So let's negative 3.204 times 10 raised to the power negative 17 coulombs divided by negative 1.6 times 10 raised to the power negative 19 coulombs. When you do that, you are going to have 200 electrons. 200 electrons. So the number of electrons that will be transferred 200 electrons. Okay, I hope you are following. Remember the rule, write out your parameters, then you go ahead and look for a suitable formula, then you plug in your value. Okay, let's quickly look at another example. Let's look at another example. Okay, it says, what is the total electric charge of 50 kilogram of proton? What is the total electric charge of 50 kilogram of proton? So let's go ahead and identify the parameters in this question. The first one is what? The total electric charge. And the second one is the total mass of proton. Total mass of proton. Now let's write them out. So we are looking for the total electric charge. Then, and we also have the total mass of proton. So we have it as total mass of proton. The total mass of proton we have, based on the equation, is equals to 50 kilogram. Then you ask yourself, what is the formula that relates the electric charge and the total mass of proton? So the formula is Q, which is electric charge, is equal to N, which is the number of proton, multiplied by the charge of one proton. But here you see that in this question, number of proton is not given, but we know the charge of one proton. So we have to go ahead and calculate first the number of proton. Then we say, but the number of proton is equal to the total mass of proton. Is equal to the total mass of proton. I hope you're following. Then divided by the mass of proton. Divided by the mass of proton. So when you divide the total mass of proton by the mass of one proton, you are going to have the number of proton. Example. So here the total mass of proton is 50 kilogram. And the mass of one proton is equal to 1.6726 times 10 raised to power negative 27 kilogram. It is a constant. When you divide that, you are going to have 2.98 times 10 raised to power 28. Because here, your kilogram has cancelled this kilogram. Then let's go back and plug it into our equation. Q is equal to, so the number of proton here is now going to be 2.9 times 10 raised to power 28, then multiplied by the charge of one proton. The charge of one proton is now going to be 1.6 times 10 raised to power negative 19 coulombs. So remember that the charge of proton is constant. So when you multiply 2.9 times 10 to the power 28 by 1.6 times 10 to the power negative 19 coulombs, you are going to get 4.783 times 10 raised to the power 9 coulombs. So this becomes the total electric charge. Okay. Let's quickly move into another question that will interest you. Good. It says, what is the electric charge of 3.6 moles of electron? What is the electric charge of 3.6 moles of electron? So as usual, we take a look at the equation and identify the parameters. So the first parameter here in this question is what? Is charge, electric charge. It's asking us about what is the electric charge. So the question asks you to calculate what the electric charge. So we write Q is unknown. That's what. So another parameter there is 3.6 moles of electron. 3.6 moles of electron. So we have it as what? Number of moles of electron. We have it as 3.6. Now we try to find out the equation that relates the quantity of electric charge with the number of moles of electron. And we have the formula as Q, which is the quantity of electric charge, is equals to the number of moles of electron multiplied by Faraday's constant. Here, let's plug in our value. Q is now equals to the number of moles of electron is given as 3.6 mole. Then multiplied by Faraday's constant has a value of 9.65. 9.65 times 10 raised to power 4 coulombs per mole. So we now have our quantity of electric charge to be, when we resolve that, we have 3.47 times 10 raised to power 5 coulombs. This mole, we cancel this mole. And remember that since we are talking about electron, so your answer will have a negative sign. So this becomes the quantity of electric charge. Okay, let's take a look at the last but not the least. Let's take a look at the last but not the least. Let's try to solve for that of proton. Okay, it says find the total electric charge of 0.5 moles of proton. So as usual, identify the parameters in the given question. It will help you a lot to know the right formula to apply. So the first parameter there is the total electric charge. So which is Q. The Q is what you are looking for. You don't know it. Then another parameter here is 0.5 moles of proton. So we have N subscript P, which is equals to 0.5. Then you try to think out of the formula that relates the quantity of electric charge and the number of moles of proton. So the formula is Q, which is the quantity of electric charge, is equal to number of moles of proton multiplied by Faraday's constant. So we go ahead to resolve. The number of moles of proton here is 0.5. Then multiply by Faraday's constant is the constant is given as 9.65 times 10 raised to power 4. So when you resolve it, you are going to get 48,250 coulombs. So this becomes your answer. So we are going to go into Coulomb's law in our next class. So do have a lovely day, and also make sure you subscribe to this channel. Please, if you have any difficult question that you would want me to help you to solve, feel free to drop it on the comment section.